All right, good evening, everybody. Today we're going to be doing practice and problem solving for solving inequalities with addition and subtraction. So let's begin. I'm going to take all the even ones by the looks of it because I've got the first one. If I look at this, it says x plus 5 is less than 7. Before we begin, just for a quick review for all of you guys at home, uh, the symbol I'm making right now is less than. And it simply means that whatever is on this side is less than whatever is on this side. It's easy to tell because, as you were probably taught when you were younger, the alligator mouth opens to let more in, right? And what can come in on this side. The next one that we're going to go over is the opposite side, and that's greater than. Now, greater than is the opposite of less than, of course. It means that whatever is on this side is greater than whatever is on this side. Then we've got two others. One of them is going to be with a line underneath it, and that's less than or equal to. And that simply means whatever's on this side is less than what's on this side, or it's equal to what's on this side, which of course makes this next one greater than or equal to. And quite the opposite, whatever on this side is greater or equal to whatever is on this side. Now that we got the fundamentals done, let's go and solve these problems. X plus 5 is less than 7. Well, to solve this, I have to subtract 5 from this side to get x alone. So that means this minus sign must mean that I'm subtracting 5 from this side. And of course, whatever I do to one side of my inequality, I have to do to my other side. Now, the symbol that's in between is going to remain the same. And so x is less than, 7 minus 5 is 2. And if we were to put this on a number line, we would see that we'd have to go to 2. And we realize that it doesn't say or equal to, it's just less than. So that means I'll make an open circle. And since it's less than 2, I'm going to make my arrow pointing to all the numbers that are less than 2. All right, let's go on to number 8. So solve x plus 10 is greater than or equal to 14. Once again, we have to subtract 10 from both sides so we can get our variable by itself. And 14 minus 10 is 4. That means that x is greater than or equal to 4. Well, if I was to make a number line here, and let's just say I put 4 right here, this time I would have to shade in my dot, because this time, as we've seen before, it is greater than or equal to. And when it's equal to something, I shade in the circle, showing that it can also be 4. Let's see. Now, I'm going to put, since it's greater than 4, I'm going to go ahead and shade in my arrow to all the numbers that are greater than 4. All right, let's try number 10 now. The maximum number of students in a classroom is 26. If there are 16 students signed up for an art class, how many more students can join the class without exceeding the maximum? Well, first of all, it says the maximum is 26, so we'll put 26 on one side of our inequality. Then it says if there are 16 students signed up for a class now, so there's 16 over here, how many more can sign up? Well, that is what we're trying to find. So we can add a certain variable. We don't know what that variable is yet. And it says how many more can join before the class exceeds the maximum amount. So that means it cannot go over 26, but it can't equal 26 because the maximum number of students is 26. So we have 16 plus x is less than or equal to 26. Now, to solve this, we'll have to subtract 16 from this side, just like we would an equation. And whatever I do to one side, I do to the other. And 26 minus 16 is 10, which means that x is less than or equal to 10. It doesn't tell us to make a number line, so I don't have to go ahead and make one. Now I'm going to go to number 12. Rena is climbing a mountain. She has not yet reached the base camp. Write an equation to show the remaining distance, which is d, in feet that she must climb to reach the peak. Okay, she's climbing a mountain. Let's just say this is the mountain over here. And it says she has not reached base camp. Okay, she's climbing it, has not reached the base camp. What inequality would show the remaining distance in feet, which means she has to be, the distance is going to be d, we'll call it, and we have to know what we're adding that to and how far it is to the camp. And there's probably a picture here that's missing, so I'm going to go find it. And there I found it. As we can see here, the information that was missing was the base camp is at 9,695 feet. The peak is at 12,358 feet. And remember, we're trying to find out how far she's got to reach the peak. Now, she has not yet reached base camp, okay? But that's inconsequential because we're not trying to find out how far she needs to go to reach base camp. They want an inequality to show the remaining distance in feet she must climb to reach the peak. So if base camp, let's just say, was here, and she hasn't reached it yet, that means whatever distance that she has to go is going to be added to this amount of distance here. Well, we can only find that distance. We see that we've got 9,695, right? And then we have 12,358. So we have to figure out how to make an equation with the information that's given. The part that's hard here is without knowing the part, the distance that she's traveled, you don't know the whole distance, but really we're talking about an inequality, not an equal sign here. So what we have to remember is that whatever she's going, since she hasn't reached a base camp, is going to be more than the distance from the base camp to the peak. So it's going to be more than, greater than 12,358 feet. So since we know that we're going to have to add, oh no, I see it here. What we're realizing is what is the distance in feet she must climb. Well, since it's an inequality, I'm going to have to think of this quite different. I would have to say that the distance, and that's what we're trying to find here, is greater than, and it says she hasn't reached the base camp, so we're not going to say that it's the same as, but it's definitely greater than, well, 12,358 feet minus, well, 9,000, excuse me, 695 feet. Does everyone see that? We know that it's going to be a greater distance than what it is from the base camp to the peak. We don't know what the distance is because they haven't told us how far the base camp is from where she was hiking. But we do know that it's going to be greater than the base camp to the peak. So if we did this, we'd have 12,358. We'd have to subtract 9,695. And let's see, we got 8 minus 5 is 3. We'll have to borrow one there and there. So let's take this out and turn it into 11. This gets turned into 12. And that's 15. 15 minus 9 is 6. And 12 minus 6 is 6. And 11 minus 9 is 2. So that means the distance is greater than 2,663, what was our unit of measure? Feet. Okay? And that's all the information we can really tell, because it does not tell us how far she went from to get to base to where she's at to get to base camp. So that's the distance. That's the inequality that would represent how much she must climb to get to there. A greater distance than 2,663 feet. Okay, we're going to move on to number 14 now. On the model with math, it says Danny's neighbor, could be Danny's neighbor, I guess, paid her to take care of a bird during their vacation. Danny spent $4 of her earnings on an afternoon snack and $16 on a new book. Afterwards, she had at least $8. At least. Okay. If she had $8 at the end, they say at least, that means she could have had more. She could have had just 8. So we're going to say that whatever she had, it was more than or equal to $8. Now, we don't know how much they gave her, but we do know that she spent $16 and $4. Well, 16 plus 4 is 20. So we know that whatever they gave her, minus the $20 that she spent, is going to be greater than or equal to $8. And since they said write an inequality to represent it, I don't even have to solve it, do I? Okay, so let's just move from there. Oh, that was the last one that I have to do. I think everyone knows if you wanted to solve this, and we're just going to go ahead and do it for laughs here, I would have to add 20 to this side, which means I would add 20 to this side, and that would make x is greater than or equal to $28. So in other words, they paid her more than or equal to $28, $28 or more. All right, well, I know it's the end of the week, and I have to go ahead and leave a clue for you, a code, and I'm looking at what my wife has made my lunch of today, and it is called, well, let's just write it here for all the people that want a treat. And we're going to make it tricky. Star-kissed, low sodium, let's see, well, there's a weird word. Albacore white tuna. All right, that is your code word for tonight. Put it on your paper, bring it in, and get a treat from me. Have a good night, and I'll see you in class.